Okay, looks like it's time to get started, and right now we're going to talk a little bit about quadratic functions. And we're going to start by talking about, well, first let's start talking about what is a quadratic function. And what we're going to do is we're going to just define this generally as a function where I've got f of x, and I will have some constant times an x squared term, plus another constant times just a plain x term, and then one final constant. So a, b, and c are going to be just numbers. Our variable's x. Now you probably notice the word quad in this quadratic function. You hear there's 4 terms. I've got a polynomial here, so I've got 2 x terms, I've got a constant term, and this f of x is essentially the y value. So we've got 4 terms. The domain of this is x is real. Now this is what we call our standard form. We have one other format for this that will make more sense if you've already done some of our function transformations, and this is what we call our vertex form. We could also write this as f of x is equal to a times x minus h squared plus k. Now, the a for both of these are the same. This is called our vertex form. So here, both of these things are going to be a parabola, and the vertex, or the highest or lowest point on this, is located at, in this case, if we use our vertex form, it would be at h and k. Or if we use our standard form, we'd say that our vertex is at negative b over 2a, and then the function at that value. Because this thing, or this ordered pair, is just an x and y, of course, this is simply the y value associated with this x. Okay, let's go ahead and I'll let you pause the video and write stuff down if you need to. But we're going to come back to this relationship a little bit later. Probably in another video. For now, let's talk about our most simple parabola. And here we're going to deal with a parabola where our f of x is just equal to x squared. So let's make up a table of values for our x and y here. So we've got our x, and we've got our f of x, and I'm gonna do a number of values here. I can go from, say, -3, -2, -1, 0, 1, 2, 3, and I'll even go up to 4 over on this. Well, because all of our values are essentially just squared, only thing I'm really doing here, when I'm thinking about this particular thing, so this f of -3 is just -3 squared. -3 times -3 is a positive 9. -2 squared is going to be a positive 4. -1 squared is a positive 1. 0 squared is just 0. And then we're going to see a pattern happening with our values. because 1 squared is just 1 again. So I've got a little bit of symmetry around this point. 2 squared is 4, 3 squared is 9, 4 squared is 16. So you'll notice that this point right here seems to be the center of this pattern. This point right here is called our vertex. And something kind of cool happens when we graph things, when we graph a parabola. And this is a really, really useful pattern that's going to pop up all over in all of our quadratic functions. And here we go. Let's go ahead and graph this puppy. No puppies were harmed in the graphing of this parabola. So, we started out, we said we had -3 and 9, so we had 1, 2, 3, and up 9, so we've got 5, 6, 7, 8, 9, right there. -2, 1, 2, 3, yeah, -2 and 4, -1 and 1, 0 and 0, and then 1 and 1, 2 and 4, 3 and 9, and if I went all the way out here to 4, I would go up to 5, 10, 15. It was actually up here at 16, which is, in fact, just off my page. But it's right there. So what would happen is I have this pattern where I've got this nice smooth curve, and as it gets further from the parabola, every point continues to go up progressively further. And here is that essential pattern I wanted to show you guys, all you people. Notice that if from this vertex, this point right here, our vertex, if I moved out 1, and I'm going to see if I can find a finer tipped. If I move out 1 from that vertex, it moves up. I know this is not going to be a big shock, 1 squared, because, well, what am I squaring? I'm squaring that 1. If I move 2 out from there, it moves up 4, or that's 2 squared. If it moved out 3, it goes up 3 squared. If it moved out 4 spaces, it moved up 4 squared places. And this relationship of distance from the vertex is preserved for all things with this x squared kind of pattern. If I had a number in front of it, I would multiply that as well. But that's all I have time for this video. I will catch you in the next one.